Welcome students. Today we are here to discuss our first topic, that is sources of energy. In our daily life, we come across various types of energy sources. We are also looking for the efficient sources of energy that we can use in the future. If already there are energy sources, or if we go back in the 9th class and recapitulate our first topic, there were a law of conservation of energy, according to which energy can neither be created nor be destroyed, but can be converted from one form of energy to another. That is, energy lost is equals to energy gained. That means no energy loss is there. If there is no energy loss, or energy does not get destroyed, then why the energy crisis is there? So, to overcome this riddle, I want to give you two examples. So, first of all, we have to think that why energy crisis is there. So, in order to explain this question, I want to tell you that energy gets dissipated in less usable forms to the surroundings. That's why the energy crisis is there. Now I will give you two examples. For example, the first example is burning candle. Burning candle gives us the chemical energy in the form of heat and light. But this heat and light cannot be collected to take back the same chemical energy that the burning candle is giving. So we can say that the energy gets dissipated or gets wasted in some different forms that cannot be used again. That is, less usable forms to the surroundings. Second example is, if we keep water at 348 Kelvin temperature first, and then we take that water container and keep it at 298 Kelvin temperature. Obviously, the temperature is low. So, the water will get cooled by leaving the heat to the surroundings. Can we collect heat from the surroundings to again heat the water? So that becomes a problem. So we can say that it becomes difficult or impossible for us to collect the heat from the surroundings that is dissipated to again heat the water. So energy crisis occurs because energy gets dissipated in less usable forms to surroundings. In order to overcome the energy demands of increasing industrialization or for various other purposes, we must look for different sources of energy. While considering these different sources of energy, we keep some points in our mind that what should be the good source of energy. According to our chapter, a good source of energy is that which has high calorific value. High calorific value means it gives us more heat energy on burning. Second is, it should be easily accessible or easily available. It should be available to all the places where we can easily use it. Third is, it should be smokeless or ashless. Smokeless, if it produces smoke, then it becomes a difficulty for us to keep the residue or where to throw the residue. So it should be ashless or smokeless without leaving any residue. It should be easily accessible. Wherever we live, we should be able to get that source of energy easily. Next is easy to store and transport. A good source of energy must be easy to store and transport so that we can take it from one place to another or store for months in so that it can be used in the future. It should be economical. It should be in our pocket money that we should be able to buy it. Next is conventional sources of energy. Conventional sources of energy are generally the traditionally used sources that we are using from years. These are actually non-renewable sources of energy that cannot be renewed. Example, wood is a conventional source of energy that we are using from years. But with the ever-increasing demand of industrialization, we started using coal and petroleum as a source of energy, that is, fossil fuels we are using to increase the demand of, to fulfill the demand of industrialization. So the main are coal and petroleum, but the problem is that these took millions of years for their formation. So these cannot be renewed easily. So this cannot be considered as good source of energy. However, we are using them to produce heat energy from these sources. It also has some disadvantages. Fossil fuels cause air pollution and produce oxides of sulfur and nitrogen carbon that lead to acid rain. When these oxides come to the earth in the form of acid rain, they can also affect water and soil resources. So we must look for the ways to overcome these drawbacks first so that we can use the energy sources that are available presently to us. So this drawback can be removed by increasing efficiency of combustion process or by reducing escape of harmful gases and acids into the surroundings. Although in every source, heat energy is required, heat energy is generally available from these fossil fuels. So I want you to see this diagram. We must use some other way in which we can convert this fossil fuel energy to produce energy that is much reusable for us. In this diagram, a pressure cooker is there in which we must heat the water. It will produce steam, and the steam is used to run the turbine, further connected to dynamo, which produces electricity and grows the bulb. The same process that is used in another forms of energy that are different from fossil fuels directly. The heat energy from the fossil fuels is further used to produce thermal power plant energy, etc. So let's see how this process is used in thermal power plants. Thermal power plants. Thermal power plants mainly uses heat energy and then gets converted into steam, and then steam is used to run turbines which are further used for electricity transmission. The same process that we have seen in figure 14.2 is used in thermal power plants. So thermal power plants are mainly basically set up near coal and oil fields because although coal and oil are giving us energy, but they are difficult to transport from one place to another. Rather, the electricity transmission is easy. So they are set up near oil and coal fields. Electricity transmission is easy. Why they are called thermal power plants? Because heat energy is converted into electrical energy. So the term is basically related to heat. That's why they are given the name thermal power plants. Next is hydropower plants. Hydropower plants are basically associated with dams. In this, the kinetic energy of flowing water is used to run the turbines and that are further used to produce electricity. These are also renewable source of energy. Let's look at this picture. In this, water from the height is allowed to move the turbines. The turbines are further connected to powerhouse generator, and this powerhouse generator produces electricity which is transported through these power lines to various stations. Although it is a good source of energy, but it has some disadvantages too. First is, it can be produced over limited places, where the rivers are present or where the dams can be constructed. Second is, to make the dams, we have to sacrifice various type of agricultural land and human habitat. Third is, while construction of dams, large ecosystems are destroyed, and also some vegetation gets submerged under the water during the dam construction. And when this submerged vegetation in the presence of anaerobic conditions, they produce large amount of methane gas, which can cause greenhouse effect. And also, this one is an important point, that on river Ganga and river Narmada, which dam construction was opposed. So you have to remember Teri Dam on river Ganga and Sardar Sarovar on river Narmada is being opposed because they cause such type of problems that we have discussed in the above points. So thank you. First of all, read this chapter, then we will give some another video to understand the next chapter. Thank you.